Now this illustration is still dealing with a supplement electrodes or supplementary electrodes in accordance with NEC 250.53, A as in apple, 3. Now notice what the note says, first of all. The parallel efficiency of rods is increased by spacing them twice the length of the largest rod. Now, if you had an 8-foot rod, it'd be a 16-foot separation. 10-foot rod, 20-foot separation. Now, that's always been, in one place, IEEE Green Book, but notice 250.53 A as in apple 3 in the informational note is telling you that's the best. That's the best you can get. But if you go to the NEC, it just says 6 foot. That creates a problem. Is it just 6 foot from rod to rod? Or is it 6 foot for this rod, and then this rod then would be 12 foot? So this rod has 6 foot, and this rod has 6 foot. One inspector said that's what you need. Personally, I think that's the best for that type of separation. And then some say, no, you put down 2 rods and you're done. Don't fall for that. If you do not have that 25 ohms or less, and you create problems in that service to ground, where you start losing that continuity to ground of the voltage to ground, and you start having electronic equipment malfunction, give problems, friend, you're in for a lawsuit. So be careful with that. And notice 25 ohms into 120 volt, that's 4.8 amp. Is what you have flowing there. So that's a basic resistant rule, you know, using Ohm's law. But you're using that in accordance with 250.53. A is an apple 2 exception. So the first rod should measure 25 ohms or less as required in 250.53. A is an apple 2, and 250.53. D is in dog 2, as you see in the illustration. And only a number 6 equipment ground is required to be routed, not equipment ground, excuse me, that's a wrong term. You'd use a grounding electrode conductor, would be number 6 per table by section 250.66, not the table. And then, of course, you have your resistance of 25 ohms listed there in 250.53. A is an apple 2 exception, and 250.53D, 2 is in dog. Now, this figure 16-71 deals with the separation from rod 1, say, to rod 2 in accordance with 250.53A3 for supplement electrodes. But the very best you can get is highlighted in the note. Double the length of the rod. And remember, it's the depth of the rod that gives you lower resistance, not the diameter of the rod, but the depth. And sometimes, you know, you screw rods together and you drive them down maybe 16 foot to get what you want. If you can't get it, separating the rods. But if you want to get the best, follow the note, double the length of the rod. So 8-foot rod, 16 foot, set your other. Now you know the basis for this. A rod driven down an 8 foot has an 8-foot radius. The closer to the rod, the lower the resistance. The further away, the higher. So that's why they want you to move over 16 foot. So this other rod has its own layers of dirt and soil that will lower its resistance to ground. You're not infringing on this rod, which doesn't seem to give you the best resistant reading. So that's what this figure 16-71 is illustrating, how you would separate the rods in accordance with the NEC, and then what would be the best. And we just explained to you the problems you might run into with supplement type electrode, supplementary type electrode. So keep that in mind when you're running into such an installation as shown in this figure 16-71.